what we want to look at here is we're going to look at the equation of a line. Okay, and so just as a quick algebra review, but we want to talk about, we're going to be using this, so I just feel like we should mention it at some point. We're going to use our equation of our line is our point slope formula. And if you remember, to find the equation of a line, you need to know slope and a point. So if I have these 2 points, my slope is, remember your slope formula, y2 minus y1. And this is going to be negative 5/4. Does it matter which point I use to write down the equation? Nope, I'm going to pick the first one. So this is minus 5/4 x plus 3 plus 2. We're going to actually do a lot with some writing the equations of a line here. What if we wanted to find the equation of a line perpendicular to a line? Okay. What do you know about parallel slopes? Same slope. Perpendicular slopes, you flip it, change the sign. So if the slope of this is 5, for my point, my perpendicular is negative 1/5. So we just write down our equation, negative 1/5, x plus 1 minus 2. Now, we don't think of that with an equation of a line, but really what you're doing with the equation of a line is you are taking our parent function and you're taking this, right, and you're transforming it. You are shifting it left or right and changing, which is what we did with all of our parent function things. So if you remember, if you use a terminology we used last year, right? If you have a plus or minus outside of the function, it moves it up or down. A plus or minus inside the function, it moves it left or right. I'm going through this quick because you've all done this before. So if I have something like that, f of x minus 2, that's going to take that function and shift it to the right 2. So it would take this and shift it to the right 2. We did this before. What about f of x plus 1 minus 2? It's going to be to the left 1. Oh, that was bad. To the left 1, maybe left 1. And now it's not going to down 2. Right? Now, we can do this with our parent functions. Oh, reflections, I forgot. Remember, we have inside the function, flips it over the x-axis, over the y-axis, excuse me. Outside the function, flips it over the x-axis. Okay. I don't have all this in your notes because this is all just review, right? Let's do some examples. So let's look at these two. Quantity x minus 3 squared minus 1 and e to the x minus 2. The first one, quadratic, and it gets moved which way? Right 3, down 1. So it's right 3, down 1. So quadratic. E to the x minus 2 is e to the x, and it moves it right 2. Now, if you think of normal e to the x goes through 0, 1. So if it goes right 2, it just goes through there. All right, flip it over the back. Try those two. Square root and absolute value. we're going forward here, you're going to need your calculator if you don't have it out. If you don't have yours with you, I got out some over there. You can borrow one. All right, square root of negative x minus 2. The negative inside flips it over the y. It goes down 2. So normally it goes to the right. Now it's going to go to the left and moves it down 2. So we have that. Second one is our absolute value, which is the v. We're going to move it right 3, up 1. With a negative in front, flips it over. So like that. Okay. Rings a bell from all those parent function quizzes we took last year, right? All right, let's talk about graphing functions. And really there's two different ways you can graph functions, and they require different skills. The first way is you can graph it with a pencil, right? Just like what we've been doing here with our parent functions. This kind of tests your ability to draw, your drawing skills, how accurately can you be, how well do you know the functions? Even if I show them to you, how well can you kind of graph them? But when we look at graphing things on the calculator, it requires a little bit more of us understanding what we're looking at, right? Being able to look at it and see, does it make sense or not? So some of the things we're going to talk about when you graph stuff on the calculator. At this point, hopefully you think about when you graph something, is it reasonable? Is that graph what you think it should look like, right? Because of the parent functions, you know if you graph a quadratic, right, you should know what it looks like. So for example, if this is our graphing window and you graph some cubic, right, and you look in your graphing window and you see that, what do you know? There's more that you have to expand or zoom out, right? Because you know that's a cubic, that's not the shape. There's more to it than you know. So that's, is it reasonable? 2, can you see all the important characteristics? When I talk important characteristics, we're usually thinking peaks and valleys and intercepts. Those are those important things. And one of the things we'll talk about a lot this year and why we need to know these parent functions is what happens to our graph as it like goes to infinity. Think e to the x. As you go to negative infinity and e to the x, what happens to the graph? It gets really, really, really closer to 0, right? Never gets there, but gets close. If you think of natural log, as you get close to the y-axis, it goes to infinity. As you go to the right, it just slowly increases. So understanding some of those basic characteristics becomes important. Not necessarily going back to your question about, you know, the exact angle or something, but what generally is happening to it. Okay. Interpret those characteristics, all that we're talking about. And then 4, recognize when there's a failure. The calculators have gotten a lot better than the older ones, but they still do dumb stuff, right? Calculators are not that smart. So let me give you an example. Consider this. Now, don't put this in your calculator yet. What is this equal to? What do you do when you have a power to a power? You multiply, and that should just be x to the first, right? So graph that in your calculator. See what it looks like. Now, it should look like y equals x, right? Straight line. Does it? Okay. So it should just be a straight line. Two things. One, it's got something weird going on around the origin. Secondly, it stops. Okay. Calculator gives us an error. There's a problem. Now, why is that? So if we zoom in close, what's going on here? Well, think about that function, x to the 201 to the 1 over the 201. When you get to be down here and your x is small, let's just think about the function. What's the first thing you do? You take a small number to a really big exponent, which is going to give you a really small number. So if I hit trace here, you can see when I'm in here, the calculator is basically saying these are all 0. Because you take a small number to a large exponent, and then the calculator basically says, hey, that's just 0. It got so small, calculator gave up and said that's a 0. So then when you raise it to the 1 over the 201, you're basically taking 0 to a power, which is just 0. Okay. Likewise, if we go out here, if we get to a bigger number, when you get out to here, you're going to take a number like that to the 201. What's going to happen? That goes the other way. It gets so big, the calculator just gives up and doesn't give you the value. So what you end up with is a graph that doesn't look quite right. Okay. But we can kind of think about that one. Now, graph that one on your calculator again. Okay. Now, my question for you is, in looking at that graph, what's the domain of range? No solution. Does not exist. So you get that. Okay. So first off, you have this. So you can't put a 1 in here because you would get a square root of a negative. Okay. What value makes the bottom 0? If you just here, let's think of it this way. Just take this to 0, and we get that, right? So if we think about this in terms of like a number line, when is this greater than 0? It would be here and there, right? Can I include the square root of 2? If I put the square root of 2 in there, the bottom would be 0, which you can't do. Okay. Okay, so we have a better idea of what our domain is, and if you trace it, you can see that goes to 1.5, right? Because the previous one is 1.4, and what is the square root of 2 in a decimal? 1.414. So it makes sense, right? Matches. What about our range? How high does that go? Does it only go to 2? Or does it keep going higher? Actually, I wouldn't zoom out. I would actually zoom in. And here's what I mean by that. I'm actually going to change my window to be smaller. Let's go to 2 and graph. And what happens? It went even higher, didn't it? So let's go 0 to 2 since it's symmetric. And let's go up higher to 10, does this keep going or does it stop? So that's what the calculator shows though. But does it stop? Or do we have a vertical asymptote there? Right? As I zoom in, what keeps happening? It's going higher. So we actually have a vertical asymptote here. So if you actually looked at this graph, this goes up forever. But the calculator doesn't show you that, but it keeps going. It's kind of like when we graph this. Similar idea. Does that truly stop when it's natural log? No, natural log just continues to go down forever, even though the calculator stops as we're looking at it. Okay. All right. Next thing we want to look at here, piecewise functions. Remember doing piecewise functions? So, like I said, we're basically like reviewing everything that we did last year in a couple days. So, do you remember how to graph a piecewise function? So let's do this. Here's what I want you to do first. Let's say we're going to graph 3x plus 1. Okay, make sure you're using pencil here because we're going to erase, right? We're going to graph 3x plus 1. So y-intercept is 1. Slope is 3. That's a horrible line, but we're going to go with it. We get to there, right? Slope is 3, y-intercept is 1. Now, we use that part of the equation when x is less than 0. So that's when our x is less than 0. So I am going to erase all of this. Now, is this an open or closed circle? It's open. Now I'm going to graph 2 minus x, where my y-intercept is 2, my slope is -1. So that is here. And there. Oh. I can't count. So there is my piecewise function. Okay. You try that one. You try graphing that one yourself. So we have 1, -2, which is like that, and that is greater than 1. So that's greater than 1. So that's like that. And the second part is -2. Is it a V? Yeah. Yep. So it should look like that. All right, let's go the other way. Let's be given a graph and find the piecewise. Now, here's the easiest way to start this. First off, as you look at that, you think, okay, how many pieces is that broken into? 3. So what you want to do is look at what is the domain over here of each piece. The first part goes from -1 to 0, right? I'm looking at the x's. So we'll say over here, -1 to 0. The second part goes from 0 to 2. And the third part goes from 2 to 5. Now, I'm going to change those. What do you think I could change about what I just wrote down that's wrong? Parentheses, yes. So this one should be parentheses, and this one should be parentheses based on the open and closed circle, okay? So the first one, this part right here, what is that, the equation of that? So you want to think about what's the slope? 1, and what's the y-intercept? 1. This part is just a constant, that's just 2. And this part is a constant, is just 1. Okay. Now, one of the things we're going to talk about this year that we have to write as a piecewise function is absolute value. We're going to do algebra with absolute value, and just using something as an absolute value equation can be difficult. It can be hard to solve. And so when we use absolute value, there are times we're going to have to think of this as a piecewise function. Okay? When we get to this later, you'll see why. And our piecewise function will be this. It is x, and I won't even use if, I'll make it like we just did our last one. It will be x if we're 0 to infinity. If we are negative, less than 0, our absolute value is negative x. Now, that seems counterintuitive. Why does it say negative? But if you put a negative number in, you would have a negative negative, which would be a positive. So you've done that before. You did this in algebra when you had an equation, right? You would solve that equation by saying, well, it could be the positive case, or it could be the negative case. And you would put it into those two different things, right? And you get two answers. That's basically what we're doing here. But there are times when we're doing some different things with derivatives, integrals, and limits and other things this year, where just the absolute value, we want to have to split it into those two cases and solve them separately as those two cases to be able to do that. Okay. All right. Let's start with composite functions tomorrow. You remember the little circle?
Oh, God. I missed one.
All right. Don't throw this right into a folder. I want to talk about what's on here first. So as you look on the front, a lot of review stuff, but at this point, you can only do 1 and 2.
Yeah.
Everything else on here deals with composition. Composition will become much, much more important this year.